This is the Chapter 6 lecture outline. This is going to be the last chapter in Unit 1, so this is the last bit of content you're responsible for the first exam. And this chapter is on glaciers, deserts, and wind erosion. All right, so glaciers, what's interesting about them is that they're both part of the hydrological cycle and also the rock cycle we've talked about in a few previous chapters. So a glacier, it's just a thick mass of ice that forms over land. That's an important distinction. So it forms over land from the compaction and then recrystallization of snow. And it also shows evidence of past or present flow as well. There are different types of glaciers. One type is called the valley or alpine glacier, and they form in mountainous regions. And one example is the Kennecott Glacier shown below. There's ice sheets, or what we call continental glaciers, and these are large scale. And the two largest are the glaciers that sit on top of Greenland, and the other one that sits on top of Antarctica. There's some other types called ice caps and Piedmont glaciers, but the two largest ones and the two most important ones on Earth are the glaciers on Greenland and Antarctica. Now, what makes them important? Well, we do have ice in other places, like in this picture, it's showing you the North Pole in the top picture, and essentially that part of the ocean is frozen over. It's pretty thick, but it doesn't sit over land, so it's not considered a glacier. What's important about the ice at the North Pole is that that ice is already sitting on top of water. So if that ice were to melt, it would not have a change in the sea level of the oceans on the planet because it's already floating in the water. It's already displacing all of the water that it would normally displace. What's interesting about the glaciers on Greenland and Antarctica is that since that ice does not already sit on top of water, any melting that occurs in Greenland or Antarctica is going to directly affect the sea level of the oceans on the Earth. So if the ice in Greenland and Antarctica were to melt, we would have an increase in sea level. And that's actually already happening. The Greenland glacier is melting rather slowly, but it is still melting and breaking apart, and it's causing a noticeable increase in sea level. So eventually, if that trend were to continue, we're going to have rising sea levels, which will make cities and other important areas of the world right at sea level. Eventually, it's going to go underwater, which is kind of alarming. So that's one interesting thing about glaciers to think about when you're reading this chapter. There are believe it or not, these glaciers move. They don't move very fast, but they do. Some types of glacier movements include plastic flow and also slipping around the ground. There is a part of the glacier that moves the most, and this is called the zone of fracture. This is the uppermost 50 meters of the glacier. Around this area, you would find something called crevices, and these are about 50 meters deep at most. But if you were to walk around a glacier and then fall in a crevice, that's probably not going to be a great thing if it's 50 meters deep, but that's about as deep as they're going to get. This is just a picture of somebody, what looks like to me being an idiot, trying to stand in a crevasse, because who knows how deep that actually goes underneath them, but this is just a picture of a crevasse that you might, or a crevice that you might see if you're walking along a glacier. Some regions of glaciers, the zone of accumulation is the area of a glacier where it starts to form. So this, again, tends to be of higher elevation. And then there's the zone of wastage, and this is going to be the area where there's a net loss of glacier material due to melting ice and melting snow. And what you have occurring at that location would be some streams and channels and stream valleys that form, and eventually that water is then moved to the ocean. And like I mentioned before, you would have an increase in sea level when this ice melts from glaciers. All right, moving on to the next topic in this chapter. This would be deserts. And this is really any situation on Earth where there's a water deficiency. And this is a distribution and causes of dry land. So if you have global distribution of air pressure and winds, you have deep interiors of land masses and presence of high mountains, you're more than likely going to be in a desert region. And all you have to do to be a desert is to be water deficient. So the global dry climate distribution, it tends to lay along the equator. So you're going to see the Sahara Desert is very near the equator, kind of above it, but very close to it. The western part of the United States would be considered a desert region. Large portions of the Middle East, and also extending all the way into East Asia, and Australia itself in the lower part of um, Africa would be considered desert or arid regions. All right, so geologic processes in these arid climates. So you have weathering. This is not as effective as in humid regions. Mechanical weathering forms unaltered rock and mineral fragments. Some chemical weathering does occur here, but since there's not a lot of moisture, this tends not to be a big factor. Sometimes you have clay forming, and then you're never going to have rich soils forming in these regions. You'll just more than likely have a thin soil that doesn't have much organic or moisture in it. So there's a role of water in arid climates. So streams are mostly dry in these areas. Some streams are called ephemeral if they are occurring at all, and these only flow during regular periods of rainfall. And there's different names are used for desert streams, including wash, arroyo, wadi, dongi, and nulla. There's going to be a picture that kind of points out a bunch of these things in a few slides. Um, there is some desert rainfall, but it's not a lot, and it often occurs as heavy showers, which can cause flash flooding if you're in a mountainous region. There is poorly integrated drainage, and then the most erosional work in a desert is done by the running water when it does occur. This is just a picture of a dry stream, so an ephemeral stream. So on the left, you're going to see most of the time it looks like that. But then when you do have heavy rainfall, you could have flash flooding occurring. So you do see the water flowing in that same area. It's just going to happen during heavy rainfall. All right, the evolution of a desert landscape. So there's a bunch of different things that could happen over a long period of time in a desert. You can have uplifted crustal blocks. You can have interior drainage into basins producing alluvial fans, playas and playa lakes. There's going to be a picture that shows all of these. Your book defines them in more detail. You can have erosion of mountain mass, which causes local relief to continuously diminish. You can have mountains are reduced to a few large bedrock knobs called inselbergs, which project above a sediment-filled basin. And here's a picture of a few of those things. So you can see some playas, some playa lakes, some alluvial fans, some inselbergs, and these tend to occur largely in the western part of the United States and really in any desert region on the planet. All right, wind erosion. All right, so essentially what wind does is it lifts loose material and deposits it somewhere else. So you can have something called blowouts occur and desert pavement being produced due to wind erosion. You could also have a process called abrasion that happens, which is just a forceful deposition of material due to wind. This is just a nice picture showing you how you could have desert pavement forming. So just make sure you read the chapter on this part and understand the main points of what's happening in this diagram. So there are types of wind deposits. One type is called loess, and this is just deposits of wind-blown silt, extensive blanket deposits, and the primary sources are deserts and then sometimes even glacial stratified drifts could be sources for a loess. You can have sand dunes, and these are just mounds and ridges of sand formed from the wind bed's load. Some characteristic features would be the slip face, so this is the leeward slope of the dune, and crossbeds, which are sloping layers of sand in the dune. So basically, they are just formed by wind erosion, and they typically have an asymmetrical shape because they just migrate with the random wind movements. And when dunes are buried, they become part of the sedimentary rock record because you could have layering occurring. So anytime you have layering sediment, that's when we're talking about sedimentary rock. There are types of wind deposits in sand dunes, and they have a bunch of different types. Just some examples: the Barchan, transverse, longitudinal, parabolic, and star dunes. And these are named basically due to the shape of the actual dune. So you're going to see the parabolic ones, the one labeled as E in the middle of this diagram, they actually have the shape of a parabola.